In physics, motion is a change in position of an object with respect to time and its reference point. A sensor is a converter that measures a physical quantity and converts it into signal. Now, there are two types of motion sensor: active sensor and passive sensor. Active sensor emit signal, typically light or sound wave, which is reflected back by the surrounding, and then the reflected signal is received by the sensor and being measured. On the other hand, a passive sensor is a device that do not emit a signal, but instead detect and responds to some type of input from the physical environment, and we will see that PIR sensor is actually a passive sensor. Passive infrared sensor, in short PIR sensor, is an electronic device that measures infrared light radiation from object in its field of view. Usually it is around 110 degrees. Motion is detected when an infrared source with one temperature, such as human body, pass in front of another infrared source with another temperature. That means when a human or animal body will get in the range of the sensor, it will detect the movement because the human or animal body emit heat energy in form of infrared radiation. And usually it's between 3 meters and 7 meters based on the module that you are using right now. Now, the term passive, as we saw, means that the PIR device do not emit an infrared light, but passively accept incoming infrared radiation from the environment. Now, for many basic project or product, we may need to detect when a person has left or entered the area or has approached, and PIR sensors are great as they can detect whether a human has moved in or out of the sensor range. And also it's worth to mention that it's a very low cost module. The module has just 3 pins, a ground and a VCC power for powering the module, and an output pin which provide high logic level if an object is detected. Also, it has 2 potentiometers, one for adjusting the sensitivity of the sensor, meaning the distance that we would like to measure, and the other is for adjusting the time the output signal stay high when an object is detected. You will probably need to check the specific range per the module you are using right now. For sensitivity adjustment, clockwise, meaning the right, will decrease sensitivity, and counterclockwise, moving left, will increase sensitivity. The same goes with time delay adjustment. We can decide how long the output of the PIR sensor module will remain high after detecting a motion. Range is usually between 3 seconds and 5 minutes. Clockwise, increase delay; counterclockwise, decrease delay. The last thing we need to know about it is that the PIR sensor requires a warm-up time in order to function properly. This is due to the setting time involved in learning its environment. It is recommended to add a delay time in the setup function. When the module is operating, in case of a motion being detected, the sensor will output high signal for a period of time based on the manual adjustment we used using the time delay potentiometer. Now we'll see how exactly we are using these sensors in our circuit, how exactly we are creating the sketch needed to operate that sensor.